Hi everyone. Today I want to talk about something that comes up in almost every AI project, but rarely gets discussed directly in the business courses. So, what happens when a team disagrees on a technical approach, and more importantly, how that disagreement actually gets resolved in practice? A lot of the conversation around AI in business tends to focus on the technology itself, the models, the algorithms, the accuracy numbers. But in my expertise, the harder and more interesting part of AI work is usually the human side of it. Okay, so I am going to walk through a real example from a project I worked on, building a custom churn prediction model and unpack the lessons that I came out of it, both about teamwork and about how to make good technical decisions under disagreements. Okay, let's start with why AI projects tend to be different from a typical software or business projects. Building an effective model usually requires a blend of skills that rarely live inside one person. You need to obtain domain knowledge, meaning a real understanding of the business problem you're solving. You need data engineering skills because raw data is almost never clean or ready to use. You need statistical reasoning to choose and evaluate models properly. And you need a clear sense of how the output will actually be used in the real world. Because a technically impressive model that doesn't fit into the business workflow isn't actually useful. It's rare for any single person to bring all of that into the table at a high level. That's actually one of the biggest strengths of working in teams on AI projects because it means you get genuine diversity of expertise. But it also introduces something that traditional software programs deal with less often, which is real ambiguity in what the right technical approach even is. In a lot of standard software engineering, there is often a clear right answer. In AI work, there are usually multiple defensive answers. And that's where things get interesting. This creates a core tension that I think is worth sitting for a moment. On one hand, diverse perspectives genuinely strengthen the output of an AI project. Different team members notice different risks, ask different questions, and bring different standards for what count as success. On the other hand, those some diverse perspectives are actually what creates disagreements. The person thinking about regulatory explainability is going to push for a different situation than a person thinking purely about predictive performance. So the challenge for any team isn't to somehow eliminate that action. That's not really possible. And honestly, you wouldn't want to eliminate it even if you would, because that diversity is valuable. The real challenge is learning how to work through that tension productively so it strengthens the project rather than stalling it. Let me walk you through a specific case where this played out. My team was tasked with building a predictive model to forecast customer churn for a subscription based business. If you're not familiar with the term, churn just refers to the customers canceling their subscriptions or stopping their use of service. The goal of our project was straightforward in concept: build a model that could identify which customers were likely to cancel early enough that the business would actually intervene, maybe with a retention offer or outreach before they did. Simple goal on paper, but as you'll see, the path to get there wasn't simple at all. Early on this project, we had a real disagreement over which modeling approach to use. Part of the team wanted to use logistical regression model. Uh, for those less familiar, logistic regression is one of the most traditional statistical modeling technique. And that's popular because it's simple and highly interpretable. You can look at the model's coefficient and explain why, um, uh, pretty clearly why it predicted what it predicted. That mattered to this group because they were thinking about how we would eventually need to explain the model's reasoning to non-technical stakeholders, like business leaders who would need to trust and act on those predictions. The other part of the team pushed hard for the gradient boosting model instead. Gradient boosting is something more complex machine learning technique that builds an ensembling of decision trees, and it tends to capture more nuanced patterns in the data. Their agreement was that it would likely produce meaningful, stronger predictive accuracy, even though that comes at the cost of interpretability or explainability. Since it's much harder to explain exactly why a gradient boosting model made a specific prediction. It is a important part of this story, and honestly, the part I think is most useful for anyone working on AI teams. Neither side was wrong. This wasn't a situation where um, someone misunderstood the technology or made a technical mistake. Both sides knew what they were talking about. The disagreement came down on differing priorities rather than differing knowledge. One group was optimizing for transparency and trust with stakeholders. The other group was optimizing for raw predictive performance. Both of these are completely legitimate goals for a business to care about, and both arguments held up technical scrutiny. That's actually what made a disagreement hard to resolve through debate alone, because you cannot really out argue someone when you are right, when you are both right about different things. Okay, so how did we actually resolve it? So this is the part I encourage anyone facing a similar situation to pay attention to. Rather than letting a disagreement stall the project for weeks, or letting it settle informally by whoever argued the loudest or had the most seniority, we agreed on a specific plan. We would test both models side by side using the exact same training and validation data for each one, so that the comparison would be fair and apples to apples. Then we evaluated both models using a standard set of metrics, specifically accuracy, precision, and recall. And just as important, we paired that quantitative comparison with a practical conversation about how much interpretability the project's actual use case really required. Not how much interpretability sounds nice in theory, but how much we genuinely needed given who would be using these predictions and how. That combination, hard metrics plus a grounded conversation about real requirements, is what turned this from a matter of opinion into a matter of evidence. So here is what data actually showed once we ran both models. The gradient boosting model performed meaningfully better on recall specifically. For anyone who needs a quick refresher, recall measures how good a model is at correctly identifying the positive cases. In our situation, correctly identifying customer who were actually going to job. And recall mattered most for our particular use case because um, uh, failing to identify a customer who was genuinely at risk of churning was far more costly to a business than a false positive. Meaning flagging someone as at risk who actually wasn't. A false positive just means the business spends a little extra, often effort and on retention outreach to someone who didn't need it. A false negative means losing a customer the business never even tried to retain. Once we framed it that way, the business case became much clearer. So we moved forward with the gradient boosting model. Sorry. So yeah, let's talk about the experience. So the experience taught me two key lessons that I think apply um, broadly to AI work. Why this one turned to this one? Let's wait. Okay. So the first lesson is that technical disagreement on AA teams is often a sign of healthy thinking, not dysfunction. When people on a team are pushing back on each other's approaches and doing it with solid technical reasoning, it usually means they're seriously engaging with the real trade-offs involved, not failing to collaborate. If everyone on the team always agreed immediately, that might actually be more concerning because it would mean people aren't thinking critically enough to about the different angles of the problem deserves. The second lesson is that the real risk in this situation isn't the disagreement itself. The real risk is not having a clear, objective way to resolve it. If our team hadn't agreed upon a fair testing process and a shared set of metrics, that disagreement could not dragged on indefinitely. Okay. Or was it could have gotten resolved in an unhealthy way by whomever had more seniority, simply asserting their maybe preference, or by whoever was more persistent or more vocal in meetings where wearing the other side down. Neither of those outcomes actually tells you which solution is better. They just tell you who was more dominant in the room, which is a pretty bad way to make a technical decision that affects real business outcomes. So if I had to distill um, so if I had to distill this into one strategy recommendation for anyone managing or working on AI teams, it would be this: let data settle technical debates whenever you possibly can. Try to avoid resolving disagreements through seniority or persistence, because that approach doesn't actually validate which solution is genuinely better. It just rewards confidence or rank within the team. Instead, build a habit of using shared evaluation metrics that are tied directly to the actual business use case, not just abstract model performance numbers that sound impressive but doesn't map to what the business actually needs. When someone agrees in advance on how success will be measured, the eventual decision feels a lot less personal, because it's not really about whose idea wins, but about what the evidence shows. So to wrap up, I think the biggest takeaway here is that strong AI teams doesn't succeed by avoiding disagreement entirely. In fact, trying to avoid disagreement altogether might mean you are missing important perspectives. Instead, strong teams succeed by building structures, shared metrics, side by side, testing clear evaluation criteria, um, and the structure is really a difference between a team that gets stuck spinning in conflict and a team that uses that same conflict as fluid fuel to be genuinely better product. For our project, that meant ending up on a model that performed better when it mattered most, while still respecting the legitimate concerns the other side of the team has raised. Thanks so much for watching.